So for Lab 5, we are going to be making solutions and doing dilutions. And the first thing I want to talk about is what actually happens when we do a dilution. So here I have represented a container that has a solution in it. So remember, a solution is where we have some particles or some stuff. In this case, that's represented by the orange little circles dissolved up in some solute. In our case, it's water. I have not shown the water molecules for simplicity. I just denoted water by that blue background, right? And so if we think about what we're doing is when we're diluting is we're taking a sample of that out and putting it into a new container. And when you take that sample out, you haven't changed the concentration. So what you see here is you see that both the volume and the number of particles dissolved up has gone down. And if we took the ratio of those, we would find the ratio is the same, right? So a concentration is just the amount of stuff per unit volume. So the concentration is still the same. But if we then dilute it, so we add some water, we change our concentration, right? Because we have the same number of particles here, but we have a bigger volume. So we have fewer particles per unit volume. So how do we figure out what that concentration is? Well, we can use our dilution equation here. So what this says is the concentration of the concentrated solution, so that's this, times the volume of that concentrated solution is equal to the concentration of our diluted solution, that's this one, times the volume of our diluted solution. And why does this work? Well, so concentration, the units we're using is molarity, so that's moles per liter, and the volume is in liters. And so you can see if we look at just our units, what we're saying here is the moles of the concentrated is equal to the moles of the diluted, right? And moles is just a representation of the number of particles. And you can see that the number of dissolved particles has not changed from here to here. And that's why this equation works, right? So if our concentrated solution was 1.5 moles per liter, and we had 10 mils of it, so 0.0100 liters, right? And we diluted that up to 100 milliliters, or 0.1 liter, right, we could figure out what the new concentration was. So if we just divide both sides by that 0.1 liter, right, we end up with 0.15 moles per liter, or 0.15 molar, which is our new concentration, and it's less than our initial concentration. So now let's think about this in terms of a serial dilution. So what does that mean? Well, a serial dilution is when you just dilute things over and over. So if you think about it, you're going to have a standard in your lab. I have my standard here, and its concentration is 1.31 times 10 to the minus 4 molar. Yours is going to be different, but the process is still the same, right? So this is my concentration of my concentrated solution, and I'm going to take a sample of that. So say I take 3 milliliters, 0.00300 liters, right? Divide by 1,000. So this is my volume and my concentration. Concentrated solution, this is my concentration of my concentrated solution, right? If I then dilute that up to 10 milliliters, I know the volume of my diluted solution, and just like in our previous example, we can then calculate the concentration of our diluted solution, right? So we're going to be able to calculate this concentration that I have marked here by a double question mark, and that's going to be my concentration for standard 2. But what if I then take some of standard 2 and dilute that? And this is where the serial part comes in. So if I then take 3 milliliters of this, I know what this concentration is because I just calculated it, and I dissolve it up to 10 milliliters. Can I calculate the concentration of my new standard? And of course I can, right? Because I have a volume, I have a concentration that I calculated here, I have a new volume, and so I can then calculate my concentration for standard 3. And of course you can just keep going, and that's where this concept of serial dilution comes in. All right, so hopefully this helps you in calculating your concentrations for Lab 5.